For a quadratic in the form ax squared plus bx plus c equals 0, the quadratic formula tells us that x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now this part, the b squared minus 4ac of the quadratic formula, is called the discriminant. So that's the discriminant, and it tells us how many real solutions, how many answers the quadratic has. So if this b squared minus 4ac is equal to 0, so if b squared minus 4ac is equal to 0, the square root of 0 will be 0. So we're only going to get one answer because we're plussing or taking away nothing. There's only one solution, one real solution. If it's positive, if b squared minus 4ac is positive, we're going to be plussing or minusing a number, and we're going to get two different solutions. So if b squared minus 4ac is bigger than 0, we get two real solutions. If it's negative, if it's less than 0, we're going to be square rooting a negative. And if you square root a negative, you get no real solutions. So if b squared minus 4ac is negative, less than 0, there are no real solutions. So we can use this, the discriminant, to work out how many solutions a quadratic has. So this question says, find the value of the discriminant and state how many real solutions each function has. So f of x is x squared plus 3x minus 5. So we're going to work out what b squared minus 4ac is. So a is 1, b is 3, and c is negative 5. So b squared, 3 squared minus 4 times 1 times negative 5, b squared minus 4ac. That's going to be 9, take away, we've got negative 4 times 1 times negative 5. A negative times a negative is positive. 4 5s are 20. So that's 29. So it's positive. B squared minus 4ac is bigger than 0. So it's got two real solutions. G of x, so we've got a is 2, b is 3, and c is 1. B squared, so 3 squared minus 4 times a times c. 3 squared is 9. Take away 4 times 2, which is 8. That's equal to 1. So again, it's positive. Two real solutions. And question 3, a is 4, b is negative 4, and c is 1. We've got b squared, negative 4 squared, minus 4 times a, which is 4, times c, which is 1. So we've got 16 minus 16, which is 0. So it's got one solution. Okay, 3 for you to try. So pause the video and give them a go. So question 1, a is 1, b is negative 2, c is 6. So b squared minus 4 times a times c. That's 4, take away 24. So negative 20, no real solutions. Question 2, b is 10, so it's 10 squared minus 4 times a, which is 5, times c, which is 5. That's 100. Take away 100, which is 0. That's one solution. And part 3, b is negative 1, so it's negative 1 squared minus 4 times a, which is 4, times c, which is negative 7. So it's 1 plus, so it's 4 times 4 times 7. 4 sevens are 28. 28 times 4 is 112. That's 113. 2 real solutions. This question says find the values of k for which x squared plus 4x plus k has no real roots. So we've got a is 1, b is 4, and c is now k. And if it's got no real roots, that means we know b squared minus 4ac is negative, less than 0. So let's substitute a, b, and c in, and we'll find a range of what k can be. So b squared, so 4 squared, minus 4 times 1 times k is less than 0. 16 minus 4k is less than 0, plus 4k to both sides. And divide both sides by 4. So k must be greater than 4. So k is greater than 4. In order for x squared plus 4x plus k to have no real roots, k must be bigger than 4. One for you to try, so pause the video and give it a go. So it's got to have 2 real solutions. That means b squared minus 4ac has to be bigger than 0, has to be positive. b is negative 5. A is 2, and c is k. So we've got 25 minus 8k is greater than 0, plus the 8k to both sides, and divide by 8. So we have 25 over 8. K is less than 25 over 8. So k must be less than 25 eighths. And this question, find the values of k for which x squared plus kx plus k plus 3 has 1 repeated root, so 1 solution. So for that, b squared minus 4ac has to be equal to 0. This time b is k, so we've got k squared minus 4 times a, which is 1, times c, which is k plus 3. So if we, 4 times 1 is 4, so it's k squared minus 4 lots of k plus 3. So it's k squared, expanding the bracket, minus 4k minus 12 equals 0. This factorizes 6 times 2. They multiply to make 12 and add. We can get a negative 4 from them. So it's going to be k plus 2, k minus 6 equals 0. So k could be negative 2 or k could be 6. So in both of these cases, we get 1 repeated root. We could, if you want to check, let's just have a quick check. So if we put negative 2 in, if we substituted negative 2 in for k, we'd get x squared minus 2x, and then negative 2 plus 3 is 1, plus 1, and that will factorize to x minus 1 squared. So 1 repeated root, just one answer, which is a 1. And then the same for 6, it'll be x squared plus 6x plus 6 plus 3, which is 9. And again, that's x, this time it's x plus 3 squared. So again, 1 repeated root, and in that scenario, it's negative 3. Find the values of k. Question for you to try, for which 2x squared plus 3kx plus k equals 0 has 1 repeated root. So it's got one repeated root. So b squared minus 4ac must be equal to 0. B is 3k. We've got 3k squared minus 4 times 2 times k. 3k times 3k is 9k squared. We've got 9k squared minus 4 times 2, which is 8k, equals 0. So if we factorize, single bracket, so k, 9k minus 8. So what makes this 0? Either k is equal to 0, or k is equal to 8/9.